let's talk about something that sounds like it's straight out of science fiction, but is very, very real.
So picture this. You take a standard stop sign, you add a few cheap, strategically placed stickers, and just like that, you cause a self-driving car to accelerate. Not sometimes, 100% of the time. This isn't a theory, this is a proven physical attack that actually works.
Did you do that?
I gave it a cold. I gave it a virus. Computer virus.
So what's actually happening here? Well, to you and me, it's obvious, right? It's a stop sign. Yeah, maybe it's a little vandalized, but it's clearly a stop sign. The car's AI, though, it sees something completely different. It sees a speed limit 45 sign. And it isn't just guessing, it's highly confident that it's right. The scary part isn't that it's confused, it's that it's so confidently wrong. And the really wild part is how little it takes to pull this off. We're talking about altering just 3% of the pixels. That's it. It's basically an invisible layer of mathematical noise that completely rewrites reality for the machine. And look, this isn't just some one-off fluke with road signs. Check this out. Researchers 3D printed this turtle with a specially designed mathematical texture. To you and me, it's a turtle. You can pick it up, turn it around, still a turtle. But to a state-of-the-art AI vision system, from pretty much any angle, it identifies it as a rifle. A rifle! Okay, so these examples are pretty shocking. But they're not just cherry-picked anecdotes. They're backed by some really solid and, frankly, kind of terrifying data. Let's dive into the numbers because this is where you really see how effective these attacks are. Now, just look at this massive gap. With just a 3% pixel change, that sweet spot we mentioned, the attack works 95% of the time. And the chance that a human will even notice something is off? Less than 1%. So you've got a practically guaranteed successful attack that is, for all intents and purposes, invisible. Oh, and it gets so much worse. You'd think an attacker would need access to the specific AI they're targeting, right? Nope. You can design an attack to fool one model, say a common open source one, and that same attack will successfully fool a completely different, unknown proprietary model about 70% of the time. These vulnerabilities are like a common cold among AIs. Let's bring this back to that stop sign. This isn't just a lab result. In real-world tests, the attack worked 100% of the time at close range, the most critical distance for a car to make a decision. Even when you back up to 15 meters, it's still succeeding almost 3/4 of the time. It is dangerously robust. So, the huge question is, why is this happening? And the answer is pretty unsettling. This isn't a simple coding mistake or a bug you can just patch. It's a fundamental consequence of how these AIs actually learn to see the world. So how on earth is any of this possible? Well, it really boils down to a fundamental difference in perception. AIs don't see the world like we do, not even close. They're not looking for holistic concepts. They're just hunting for statistical patterns. And that hunt leads them to rely on what researchers call brittle features. Think of these as statistical shortcuts. They're patterns in the data that are completely invisible or just meaningless to us humans, things like high-frequency textures or weird pixel artifacts. But for an AI, they can be a dead giveaway. This example just illustrates the point perfectly. Researchers made an image with the clear shape of a cat, but covered it in the texture of elephant skin. A human instantly says, cat. The AI? Elephant. It prioritized that brittle feature, the texture, over the robust, obvious one, the overall shape. This whole situation creates a fundamental imbalance. In the conflict between the people building AIs and those trying to fool them, the attackers have a massive, built-in advantage. It's an asymmetric war. And here's the crucial point. An attacker only needs to find one tiny, invisible pattern that works. Just one. The defender, on the other hand, has to anticipate and protect against every single possible attack, out of a near infinite number of them. It's a completely impossible task. And the data shows this plain as day. The best defense we have right now is something called adversarial training, but it only has about a 50-50 chance of stopping an attacker who's adapted to it. It's a coin flip. And simple defenses, like just blurring the image, they barely work at all. This leads to the core dilemma. See, we can make models more secure and more robust against these attacks, but doing that comes at a huge cost, a 20 to 40% drop in its accuracy on normal everyday tasks. You make it safer, but you also make it significantly worse at its job. And let's be real, no company wants to ship a product that's 40% less accurate. So, we're left with this really heavy question. If the very perception of our most advanced AIs can be hijacked by something as simple as invisible static or a few stickers, we have to seriously ask ourselves, how much of our world should we really be trusting it with?